Hi everyone, welcome you all for building a convolutional neural network using Keras session. Here the convolution is the process of multiplying matrix of pixels of given input image with filter, or it is called kernel, and the multiplication of that each and every pixel with kernel values are adding to form the scalar value. So here the feature map is forming. This is the feature map after convolution process. So here the filter is sliding over the input image based upon the feature map is created. Here the sliding is moving the filter over the input image pixel by pixel, that is based upon the stride value. So stride we can take as 1 or 2 based upon our application domain. Here one of the parameter is padding. It is having two values. One is the same, which is ensuring the filter is applied to all the elements of the input. That means padding will be added. That means zero padding. So zero will be added in all the sides of the input image, bottom, top, left, right, and all the sides will be added into the zero padding. So that will be indicated by using the same. And if it is valid, in the sense we will not add the padding. Okay, here we will not add any zeros along all over the sides of the image. So due to that, there is the possibility of only it is having original elements of the image. So here we are not adding any zeros here. So due to not adding the zeros, only the pixels which are available in the input image only is it is using for creating the feature map. In this, one of the disadvantages, you look at that. So this is 3 by 3. So here the filter is having 3 by 3 size. So when you are moving one more pixel ahead, right, so it will go like this. So after that, suppose if you are having stride equal to 2, so when you are using the stride equal to 2, so what will be happen, the next stride, I mean next time, it will move like this. So there is the possibility of it will not take these pixels to find the feature map, because there is no another column of pixels available here. So there is the loss of information in the elements on the right side of the image when you are moving the filter through the from the left to right. At the same time, here you look at that stride equal to 2, in the sense here this will come this side. Okay, in the when you are moving down the image. So here also there is the possibility of loss of information, so it will not create the feature map for these two pixels. Okay, so that is the issue will be happen when you are not using the padding, right? So number of elements here are ignored depends upon the size of the kernel. That means the how many pixels will be ignored if you are not using the padding, that is depends upon the kernel size and the stride value. Because when you are using the stride one, it is applicable to find the feature map without loss of information. But when you are using the stride equal to 2 in the same example, there is the possibility of losing information in the right side of the image and the bottom of the image. Here we are having so many steps to build the CNN model. One is loading the data set into the design model designing platform, and exploratory data analysis. That means just we are checking our data which is loaded into the platform or not, and data pre-processing, building the model. After building, we have to compile the model, then train the model and test the model. We will see that one by one here. First step is loading the data set. Here we are going to use MNIST data set, which is already available as a part of Keras library. So we are easily load the data set into our platform by using the keras.datasets, importing MNIST MNIST class. Okay, so in this everything is available for the for the processing of data set. Okay, so and here the data set is having 70,000 images, in which we are going to use 60,000 for training and 10,000 for testing process. Here x underscore train and x underscore test are the variables which are going to have the input features for this process to design the model. So x underscore train is going to have the features of training images, and y underscore train is going to have the actual output of this training images, and testing data set which is going to have 10,000 images. So test feature x underscore test which is going to have the features of the given data set, and here y underscore test is going to have the corresponding output of this actual output of this samples. And here the second step is we are going to check the input images are loaded into our platform or not. Just we are verifying that process. First we are going to check the visualization, is it visible or not. So here for that we are going to use the matplotlib. So here just we are showing the first image in the training data set x underscore train of 0, so which is displaying the first image which is having 5 is the digit, and we are going to plot the first image in the data set by using the x underscore train of 0 with the shape. So just we are trying to identify the shape. So the image size is 28 by 28 pixels, that means 28 number of rows and 28 number of columns of this given image. Third step is data pre-processing. Just we are going to reshape the data set of the training data set x underscore train, and so here the testing data set which is used to train the model. So here we are going to mention the argument with 60,000 number of images for the x underscore train and 10,000 images for x underscore test, and the shape of the image is 28 by 28. So this can be represented here, x underscore train equal to, this is the variable going to have our all the images of training data set, x underscore train reshape of that each and every image. So here 60,000 number of images, and so this reshape is indicating already we are having the x underscore train variable here. Okay, so this x underscore training variable is going to have the image size 28 by 28. So we are going to alter that by using the reshape. So here we are creating 4D tensor. So here it is having the 2D tensor, right? So here we are going to create the 4D tensor. So 60,000 is number of images and 28 by 28 width and height of the image, and here grayscale image. Okay, so here we are using the grayscale image, that's why we are using 1. Suppose if our image is color image, then we will use RGB channel, so that's why we will use 3 instead of 1. And here x underscore test is the variable which is going to have the testing images. Here already we assigned, so we are going to reshape that into 10,000 images for the testing data set. All the images are having 28 by 28 grayscale image. Then here the actual output y underscore train and y underscore test, so these are all the actual output values. So for that we are going to use one hot encoding, because here we are having 10 digits, always we are having 0 1 etc 9. Okay, so due to having 10 digit, here we are going to use the softmax classifier at the end of the output layer. So softmax classifier will give you the probability values, so that we have to use one hot encoding for the output, I mean the output target output values. Instead of having only the single digit, we are going to use one hot encoding. Here the first image in the 5 training data set, here we are going to display in the form of by using one hot encoding. So for that we need the method here to underscore categorical. We are importing that method. So here that method is converting all the training actual output values into the one hot encoding. For example, suppose if my data my input data is 5, its corresponding one hot encoding will be like this. It is not a 5, this is a 7. Okay, so here if my given digit is 7, then it is giving highest probability value in the position of 7. So 0, this is 0, 1, 2, 3, 4, 5, 6, this is 7, 8, 9. So remaining digits are representing as zeros, only the 7 is indicated with highest probability 1. So like that, testing variables, testing actual outputs also converted into one hot encoding. So here for building the model, we need to download, we need to import sequential method, because we are going to arrange the all layers in sequential way. So this is input layer, then hidden layer 1, then hidden layer 2. So like that, we can arrange any number of hidden layers in the neural network with input layer and output layer in series manner, that means sequential manner. So that's why we have to import the sequential method. Then this dropout is used for regularization. Dense is indicating the fully connected layer, that is all the neurons are connected to every neuron in the next layer, that is the meaning of dense layer. Then flattening for transforming the matrix in pixels into vector pixels. And here we are going to use the optimizer, stochastic gradient descent. And the convolutional, we are going to use 2D convolutional, and max pooling is 2D. So here just we have to create the model with the method sequential. Then we are going to add. So now we have created the structure for the model in sequential manner. Then we are going to add the convolution, 2D convolution, which is having 25 number of filters and 3 by 3 filter size or kernel size. Then input shape is 28 by 28 by 1. That means our input is here 28 by 28 pixels. So it is having 784 pixels. So it will be converted into here 784 pixels, x1, x2, etc., x 784. Then here I am going to use filter here parameters. So 9 parameters, that is 3 by 3. So 3 by 3 filters I am going to use. So it will be connected based upon the convolution structure. Then here we are going to use 25 number of kernels. This kind of kernels, 25 number of kernels we are using for extracting the information from the input features. And we are using relu as a activation function in the hidden layer 1. Okay, so here we are going to use relu activation function. So after that, now we have created one hidden layer. This is hidden layer 1. We are going to add one more convolution 2D, so which is going to have 50. So this one again we are going to one more hidden layer which is having feature map size is 3 by 3 and 50 number of kernels. Okay, 50 number of kernels we are going to create, and activation function is relu for all the neurons in the H2. So then we will get here feature map. Am I right? So when after getting the feature map, what we will do, we have to convert into the vector. So for that we need to use flatten. Okay, so for after that after that flattening, we will get vector. So here x1, x2, etc., xn. Then we are going to create 10 number of neurons, dense layer, fully connected layer. We are going to add with this fully connected layer which is having 10 neurons. Then here, since it is the multi-class classification, we are going to add softmax classifier here. So like this we can create the input layer, then hidden layer 1 and hidden layer 2. So this is hidden layer 1, this is hidden layer 2, then here flattening, and then fully connected layer, that is the softmax. Okay, so 10 number of units. So here softmax is used for the multi-class classification. This is for 0, this is for 1, etc., and here this is for 9. Okay, so like this we can create the neural network structure for the convolutional neural network. Thanks for watching.